Okay, section 5.1, and we want to talk about a general antiderivative. So, we've been doing all this with the logarithm function. So let me do antiderivative of 1 over x dx. Now remember, we defined the logarithm function as the definite integral starting at 1. So if I'm just given this, actually, unless we know something about the domain of this 1 over x in particular, actually the answer to this is the natural log of the absolute value of x plus c. So where the heck did the absolute value come from? Okay, but that is the case. If I just see a general antiderivative like this, why would that be the case? Well, let's take natural log of the absolute value of x. And now what this is this is defined as the natural log of x as long as x is greater than 0, but it's the natural log of negative x because that's the definition of absolute value if x is less than 0. Okay, well, so if I take the derivative of this thing, so the derivative natural log of the absolute value of x dx, anywhere but 0, well, obviously, I hope obviously, we get 1 over x if x is greater than 0. Now, though, notice, let's look at what we get if it's not. Well, we get the derivative. We need a chain rule here because we'll get 1 over negative x, but then times the derivative of what's inside there, so that's negative 1. And that is also equal to 1 over x when x is less than 0. So you see, we get these same 1 over x in either case. And so if you get a general antiderivative of 1 over x, the answer, at least until you know something about the domain of x here, what interval you're on or something like that, that answer is the natural log of the absolute value of x plus c. So that's one that can catch people a lot, okay? But it's just, in the end, it's that simple in the sense of, hey, if I see an antiderivative for 1 over x, just remember I need absolute values. So there we go.